where and how kidney stones form can really matter even to the patients who form them. This is a very complex video because I'm going to use two different articles, and it's my first effort at such a thing. So bear with me and let's hope for the best. Now, the first thing I want to tell you about is where in the kidney stones form. And I can't tell you that if you don't know how kidneys are put together. So, if you don't know how kidneys are put together, then you want to go down to this link right here, click it, and go to this new article in which I will show you what the kidney structures look like and where the stones would form. If you already know this, skip on. Just stop, move forward, and go to the next part of the video. This article itself is just wonderful. It tells you how kidneys function, but as part of it, it shows their anatomy. When you get to the article, you want to scroll down to this stock picture, which I took out of the web. This is a kidney. They look exactly like a big lima bean. The physical size of a kidney is about that of a clenched fist in an adult. Here's the ureter, you know what that is, and that drains a big sac-like area called the renal pelvis. And off that pelvis are a number of branches. And this is the area where we're going to be most interested. If you look into this branch, it's really in 3D, right? In other words, this is a chamber that will hold the urine and get it into the ureter. In this cutaway, you can see a region of the kidney comes down into that opening here. And this would, of course, be sealed off. This is the area called the renal papillum. It's the end of a whole piece of kidney, kind of triangular shaped. If you look a little higher up, it's a different view of it. This is the same area. It's called the renal papillum. And it is an extension of the whole kidney. This would be a whole piece of kidney. The outer rim of the kidney, this part's called the cortex. In here, the medulla and papillum is a contiguous portion. In this cutaway, you can see it even a little better. This is the cortex, and then that cortex has a funny little line running through it, and then below that, what's called the medulla and the papillum. And here it's even more cutaway. Here you can see the cortical rim, and you can see how it gives way to this darker colored medulla and papillum. And there's a kind of a disconnect here. You sort of wonder what might be in that space. This whole thing is called the renal pyramid because it looks like a pyramid. All right, that's your basic idea. As you can well imagine, because this is the region where the final urine comes out of the kidney, this is exactly where the stones form, right here, on the tips of these papilla. Now I'm going to move down and show you what's in these regions. In this kind of anatomical sketch, which I took off the web, it's one of many. This is the outer cortex. It's the outer surface of the kidney. Here's that cortex, which I showed you. Here's that funny little line I said separates the cortex from the medulla, and then the papillum. And they're not separate areas. They're kind of the one gives way to the other. And it's kind of apparent from this drawing why. Some tubes go down all the way. Other tubes just stop at various levels. We're going to trace out the way the kidney is put together and how it is you have to have the cortex separate from the rest of it. These little balls are the glomerular filters. It's the place where the kidney filters water and salt out of the blood. These filters sort of hang off of an artery. That's what these are. They're very tiny arteries, like oranges or apples on a tree. The vessel they hang off of is the thinnest possible artery. It's called an arteriole. Inside the capillary tuft is where the filtration occurs. And the blood that leaves this glomerulus will go on to nourish the tubules of the kidney. So the blood from the heart goes into this vessel, this trunk. The various glomeruli come get their blood off it like stems of a peach or an apple or a pear. And then after the blood has been filtered, it goes back out again and provides blood to the rest of the kidney. That region you saw that seemed to separate the cortex from the medulla, that's where the vessels run, the so-called arcuate vessels. They run in an arc. And then these vertical trunks are called the interlobulars because they demarcate a region of kidney separated by the vessels. It's really quite a beautiful architecture. Now, the glomerulus sits inside of a globe, a sphere. The blood comes in, the capillaries sit inside this sphere. It's called Bowman's capsule. And the filtrate of salt and water comes out into this tubule, which is called the proximal tubule. And it kind of moves back and forth. It's called convoluted. And it comes down into the deeper part of the kidney, the medulla, and then goes back up. As it comes back up, it meets its own glomerulus right here, just where the artery comes in and where the artery that's leaving goes out. It's called the juxtaglomerular apparatus. It's a way that the filtering system can get a signal from what's going on downstream, and that allows it to adjust its filtration to keep the delivery of salts and water steady here. After that critical junction, you get what's called the distal convolution, and then it drains into this kind of pipe. It's called the collecting duct. Many, many, many different units drain into this duct. And then further down, there are more of these pipe-like ducts that drain into each other and into each other and into each other. The kidney has 1 million of these glomeruli, each one with its own tubule, makes a hairpin, comes back, rejoins, and goes into a collecting duct. The collecting ducts then branch like streams into a river. At the end of the game, each of the final terminal collecting ducts will open out and urine will come out. Here we show only one on this papillum, but there will be 10 to 20 on a papillum, roughly, and they will each have gathered fluids from all the different nephrons that are drained in that section of the kidney. And these are called the ducts of Bellini, the final place. And this is where stones form, right here at the end of the game. I have now returned back to chapter 2, and we're going to look at how stones can grow. This is not a drawing. This is a photograph from a video made during a stone removal surgery. This is a renal papillum, the place where the collecting ducts that drain the final urine out of the million nephrons of a kidney come to. Here's a stone growing on the surface of the papillum. This is a patient in the operating room. The stone is removed, and this is the stone. This part of the stone is entirely calcium oxalate. In the middle, this white area, is calcium phosphate. This stone grew attached to the papillum on this white cloud, precisely this one. And this calcium phosphate attached onto this cloud-like material, which is also calcium phosphate, and is called Randall's plaque. Here's a lot more of that plaque. It looks like clouds. Any one of these areas could be a site for a stone to form. Now, the plaque does not form on the surface of the papillum. You can see the surface is covered by a kind of shiny membrane. The plaque is underneath the membrane. The urine does not contact it. If the membrane breaks and the urine is allowed to contact the calcium phosphate of the plaque, calcium and oxalate and phosphate in the urine are then able to grow on the plaque. The plaque is anchored in the kidney tissue. And so layer after layer of calcium phosphate and calcium oxalate can grow over the plaque and gradually build up a stone. It's apparent from this one stone, and you can show it in thousands of similar stones. The first thing that happens is a buildup of calcium phosphate from urine over the calcium phosphate that's buried in the tissue. Gradually, the calcium oxalate forms over that to make the body of the stone. And that's how your common calcium oxalate stone can be formed. Now, let's go down in the article a bit until we come to this remarkable, wonderful human sample. It is a part of a kidney papillum removed from a kidney, a human kidney, with plaque embedded in it. This plaque has its stalk, and over it, its stone. This is not an artifact. It is not a mock-up. It is not a model. It is not a computer-generated image. It's real. Down here is papillary kidney tissue. This is an open collecting duct. Remember the big duct I showed you? This one has crystals around it. There are other openings that would be ducts. They look like empty spaces here. This gigantic mass is calcium phosphate physically growing in the kidney tissue. It's black because it's been stained using a stain to bring out the crystals, separate from the kidney, which is stained with a separate kind of dye. This is the stone, just like I showed you. This is where the calcium phosphate was in the stone, but here we have the physical stalk of calcium phosphate. It's a little longer than usual, so it looks like a real neck. So what happened here is this material built up in the tissue, probably over months or years. When it was covered over by the shiny membrane of the papillum, it would have been just a white cloud. Remember, it wouldn't have been black. There was no stain. It would have been a white cloud. The membrane gave way. The calcium phosphate from the urine grew over the plaque. It's calcium phosphate on calcium phosphate. And this gradually got overlaid by rings of additional mineral, mostly calcium oxalate. And this is a different view of how the stone forms. It's a marvelous example. The link takes you to a complete article which uses that picture as a header and is highly technical. It was done by my colleague, Dr. Andy Evan, and myself, and it's a big, heavy thing that most of you are probably not going to read. But even so, I'll plug it here in case anybody wants to come. At this point, we've pretty much covered plaque and how stones form on it. And this mechanism accounts for a certain fraction of stone formers. Plaque looks kind of ominous in this picture, but in fact it causes little tissue injury, and as far as I can tell is fairly benign. A few more points in passing. Kidneys from normal people make plaque. It seems to be kidneys like to make it, but kidneys of stone formers make a lot more plaque, raising the risk of making stones. I'm not going to show pictures of it, but in general, the higher the urine calcium, the more plaque. The lower the urine volume, the more plaque. So the same measures that are good for stone prevention, good urine volume, control of urine calcium, are probably good for plaque. But that's never been tested, and that's just a conjecture. Now I want to move on to plugging, the other way to make a stone. And it is essentially a much blunter and a more obvious thing than plaque. Here is a kidney papillum, again in the operating room. This is the end of a terminal collecting duct, a Bellini duct, where the urine would come out of the kidney tubules in this area of the kidney, be one of 10 or 20 on this papillum. But this one is plugged with crystals. This is a mass of crystals filling that duct. Here's a little bit of plaque. This is an eroded area of the papillum. It's like there's been a little loss of normal contour, perhaps some injury. If I go down just a bit, this is a kind of lucky view, kind of catching some plugs from the side. This would have been the opening right here. And this is the plug filling the duct. Here's another one. Here's a third, but it's not in good focus. This is a little bit of plaque. This is along the side of a papillum. So this end of the plug, which is facing into the urine, would have behind it this length of plug blocking off and filling the tubule. Now this is not the same one as that. We're not that lucky. But it's a pretty good pair of images. If you looked inside this tubule, if you cut across it and did the histology, the lining cells in here are dead. All the cells that once lined this tubule are dead. What was once a complex living biological suborgan is now just a space filled with crystals. If you did histology, around this plug there would be inflammatory cells. This is a damaged area of kidney. I might point out, every single Bellini duct drains somewhere around 5,000 of the million nephrons in a kidney. So you can imagine that plugging is not so benign. It's not just that you get inflammation down here. The nephron, remember, goes all the way up into the cortex of the kidney. And fluids will back up in there, so-called internal hydronephrosis, and you can damage those nephrons that would have drained here. This is plugging. What's on the end here? What's this stuff out in the urinary space? It's crystals from the urine that have grown over the open end of the plug and are beginning to make a little tiny kidney stone. Can it grow to become a stone? Why not? It's anchored here. The urine is flowing perpetually from all the other Bellini ducts over this, and over time it is free to become a stone. Not to belabor the point, but the text goes on to say what I just said, and I'm not going to repeat it. But you might ask, do you have any evidence, any actual information showing that there is damage higher up? The answer is yes, and it's really right here. Now this is complicated. I'm not terribly apologetic. This is the cortex, the outer part of the kidney. And I'm not going to go over all the dots. I'm simply going to show you something. This is the cortex from a routine calcium oxalate stone former whose stones grow on plaque. These are all the tubules, the proximal tubules. These are those glomeruli I told you about. Look how beautiful and organized this is. This is a cortex from a patient with calcium phosphate stones who has plugging. It's not as organized. There are areas like this that show damage, and tubules are separated. Does the whole cortex look like that? Of course not. If it did, the person would be in serious trouble. But it is present. These injuries do exist. The top is another patient with calcium phosphate stones. Same story. This is the tubules here, see, like here. But there's scarring, there's damage. Some glomeruli have been destroyed. So, yes, you can find patches. Now, these would be little patchy areas in the cortex. Most of it's fine. Most of the cortex of most stone formers, even with plugging, is fine. But there is cortical injury. If you want, when the video is over, you can check out the dots and what these various types of injury mean. But basically, I've told you what it means. Now, what I haven't mentioned before is, first of all, who gets plugging. Plugging is a characteristic of everybody with systemic disease and kidney stones. Certainly almost all, or perhaps all. It is also a commonplace in uric acid stone formers, in cysteinurics, and so on. And I'm going to go through a little bit of that for you. Uric acid stone formers have plugs. They also seem to form stones that just grew in solution. What does that mean, grew in solution? Well, they're round. They don't have any special attachment sites. And there's no reason to believe they grew on anything. How could that happen? Well, the atoms and molecules in the solution can form nuclei, and they can grow, and they can become crystals, and they become stones. And I think that's what happens. Medullary sponge kidney, when you read the article, you can click on the link, has blind end sacs and off the collecting ducts. The urine is in those sacs stagnant, and they fill up with tiny, tiny stones, thousands of them. Tiny size and roundness suggests that they grow in free solution. In cystinuria, another one where there's a link, you can read about it. They're cystine plugs, but they don't stick in place. They don't damage the walls. These plugs are common, but stones never grow on them. We suspect the stones just form in solution. There are, however, dilated ducts with inflammation, and I might comment that cystinuria seems to damage the kidneys more than most diseases. Now, what can I say to sum all this up for you? First of all, stones can grow on plaque, stones can grow on plugs, stones can form in free solution. Growing on plaque is characteristic of the routine calcium oxalate stone former. Growing on plugs is characteristic of virtually all other kinds of stone formers, except uric acid and cystine, perhaps. Plugs damage kidneys, and therefore they're a worry. When the doctor does a ureteroscopy or looks in a kidney and sees a lot of plugs, it means there's a great urgency to preventing more stones and more plugs. The same treatments that prevent stones will probably prevent plugs, because the stones are, after all, growing in the urine, and the plugs are forming in the urine at the end of the collecting duct. So the treatments are probably the same. If there's a lot of plaque, there's a lot of reasons to believe there'll be more stones. So your efforts to prevent go way up. You want to ask your doctor how much plaque and how much plugs. When the doctors talk about plaque and plugs, You now know what it means. That's as far as I can take you. I hope you've enjoyed the ride. When you get a chance, read the article and go to the links, and you can learn even more. This is Fred Coe. Bye-bye.